Hello, welcome back. Today, let's try the Leetcode daily challenge problem 215, case largest element in an array. So for our example, it is a nums for this nums, and we need to get the second largest element. As we can see in this array, it is the 6 is the largest, and the 5 is the second largest. So we're gonna return 5. Yeah, so if k equals to 4, so the largest is the 6, the second, the third, and the fourth. So we're gonna return a 4. If there are equal numbers, it doesn't matter. We just need to take the false numbers. So we are not going to solve it using sorting. So we're gonna use another way, because when we are using sorting, it is n log n time, but we're gonna optimize it to k log n time. So this will be a heap data structure. So for here, I'm going to use a heap. So for heap, it is easy to calculate the largest element or the smallest element. But for case element, if this k is not a big number, basically the heap is much faster than the sorting method. Yeah, now let's just use the heap method. So in Python, we have the heap API. So first of all, because this is the max heap, because we want to calculate the case largest numbers, so we're gonna turn these nums into the negative numbers, because these numbers, whether it is positive or negative, if we want to use a max heap, we need to turn these numbers into the negative numbers first, and then we can pop out the minimum number, but there's a negative sign. For example, this is minus 6, and then we pop out it is minus 6. Because in Python, it has only min heap. Yeah, we cannot use the max heap directly, so we have to turn these numbers into the negative, and then we can use the min heap as our max heap to calculate the case largest numbers. Yeah, for other languages, you can use the max heap directly, but for Python, there's no max heap, so you have to use the min heap as our max heap. So first of all, you need to turn the numbers into a negative number. If it is a positive, turn it to negative. If it is a negative, turn it to positive, but it has no influence to our result. Yeah, because numbers, it has positive or negative. But if we give a negative, and then we can use it as a max heap. So for it would be minus n for n in nums. So this operation turn all the numbers to its opposite, and then we just gonna heapify. So inside a heap we have the many operations like heap.heapify. So here we don't need to use a heap. We can also use a heapq.heapify. Yeah, but for the Leetcode API we don't need to import. Yeah, but maybe for others you need to import the heap queue, because heap queue is a priority queue, so it is used. So this priority queue can use it for the min heap. So we need to import the heap queue. Yeah, now we can use the heap queue.heapify nums. So for this operation, this is just on time. Many people think this is n log n time. Actually, it is not, because when we are using the heap, it used the balanced tree data structure, binary balanced tree. It will prepare the last layer first. So for the last layer, it just takes O1 operation, and then the second layer. So that is why it is not n log n. So in total, that is just On time, because for the last layer, the second layer, yeah, it has many nodes, and it didn't take so many time. It is just O1 and O1. And when it goes to the top layer, there's only one node. It is log n time, but there are not so many nodes. So that is why for the time complexity for heapq.heapify is just On. Yeah, that is why it is faster than the sorting method. Now the heap, so the nums has already been turned into a heap by this syntax heapq.heapify. Now we just need to pop it out. So for I in range k, because there are k numbers, so we need to pop out k times. So the result should equal to heapq dot heap pop. So this operation is just to pop out the nums. Yeah, but we need the positive number. We need to turn the numbers into the, for example, before it is positive, and now minus n, it means it is negative. But our result should always be the positive, so we need to turn this number into positive. After that, we're gonna return our result. So here, we're gonna prepare. Yeah, so this result is still okay. Now let me just run it to check if it is okay. So expected 5 output -1. Now let me prepare result equals to 0, and here print out the num. Oh, so here is nums. This should always be nums, and yeah, now let me just delete that. I think I just have a typo. It should always be nums. Now let me run it to check if it really works. Yeah, this one should be nums. Yeah, as you can see, it works. So for this one, because we just take a temporary result, after that it will be updated. But we need to return the final result. So this is why we're gonna take this result as our result. Now let me submit it to check if it really works. And by the way, the time complexity is k log n because this is a k loop. And inside heapq.heap_pop only takes a log n time. N is the length of nums. So this is why it is k log n. Yeah, so it is the maximum of k log n and n. So the time complexity should be max of n and k log n. Yeah, so it depended on these two numbers. Yeah, so this is the final result. So this is also why that is so fast. Now let me just simplify this one. Actually, we don't need to import because in Leetcode, the heapq has already been imported automatically, so we don't need to use heapq. We just need to use heapify, and here we don't need to use heapq. Let me delete it. Just need to use heap pop this nums. Yeah. Now let me run it to check if it really works. Yeah, as you can see, it works. Now let me submit it to check if this also works. Yeah, because basically we don't need to use that because in Leetcode it has already been imported for us. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you.